solve for x. So they give you an absolute value inequality. So we have absolute value and inequality, and I need to be able to solve for x. Now remember that you need to show me each of the steps. So first, I want to be able to leave the absolute value by itself. So therefore I need to be able to leave that x minus 3 by itself. And once I have it by itself, then I can separate it into two different inequalities. First, I want to move my 6 to the right. It's a positive becomes a negative 6. Remember to rewrite this. Negative 5 absolute value of x minus 3 is greater than negative 20. I still need to leave the absolute value by itself. So therefore, I need to get rid of the negative 5. It's multiplying. I'm going to divide by negative 5 on both sides. The 5's cancel, the negatives cancel. So absolute value of x minus 3. And remember that whenever you divide by a negative number, don't forget to flip the inequality. Negative divided by negative is going to be positive. 20 divided by 5 gives me 4. And now I have two solutions. The first one was, whenever you have absolute value, you end up with two solutions. The first one will remain exactly the same. X minus 3 is less than 4. The second one will be the opposite. That's a positive x becomes a negative x. That's a negative 3 becomes a positive 3. Move my 3 to the right becomes a positive 3. And I'm going to solve each one. X is less than 7. Move my 3 to the right becomes a negative 3. Negative x is less than 1. I'm going to divide by negative 1. The negatives cancel. So x is greater than, don't forget to flip the inequality, 1 divided by negative 1 is negative 1. Now one of the things that you have to remember if this is an AND or an OR. If it's less than, it's going to be an AND. If it's greater than, it's going to be a OR. Remember, L, land. Now, be careful. Look at the inequality before you divide into two sections. And that's what this step is very important to show. This is less than, so therefore automatically this is a AND. So whenever you graph it, they should be crashing against each other. So let's see. At 7, it'll be open because there's no equal sign. At negative 1, you'll be open as well because there's no equal sign. All the numbers that are less than 7 are to the left. All the numbers that are greater than negative 1 are to the right. So your solutions will be anywhere in between. Now remember that we place it open to indicate that negative 1 is not a solution. And here it's open because 7 is not a solution. Only the numbers less than 7. And the numbers that are greater than negative 1. Now for letter C, it says choose a point that is part of the solution set. So you can select any of the ones in there. So let's go and select 0. That might be a little bit easier. So we're going to say x equal to 0. And then verify algebraically. So therefore I need to check to see if that's a solution. I'm going to plug in x equal to 0 in the original equation, negative 5. But instead of the x, I'm going to plug in 0. Minus 3 plus 6. Remember, I'm not going to solve it. I'm just going to simplify the left and the right. The right's already simplified, so I don't need to do anything with negative 14. 0 minus 3 will be just negative 3. Negative 5 plus 6. Now remember to simplify your absolute value all the way through. The absolute value of negative 3 will be 3 times negative 5 plus 6. That gives me a negative 15 plus 6, which is negative 9. Is that greater than negative 14? So is negative 9 greater than negative 14? Yes. Now choose a point that is not part of the solution. So you can select any point that's not, you can select any points here, or any points on the right, or you can select negative 1 because that's not part of the solution, or 7. In this case, let's go and plug in x equal to negative 2. Not equal to, right? Let me write it a little smaller. Absolute value. Instead of the x will be a negative 2 minus 3 plus 6. And I must simplify this. Negative 2 minus 3 is negative 5 plus 6, negative 5. Remember, always take the absolute value first. Absolute value negative 5 is 5, multiplied by negative 5 plus 6. That will give me a negative 25 plus 6. That gives me a negative 19. Is that greater than negative 14? No. And remember, it is false because negative 2 is not a solution. So you verify it algebraically as well.